Everyone back? I think it looks like we're still not missing anybody, so. All right. So you can close out that particular IPython notebook and you get back to this dashboard and we go to part 2, how to speak MPL. And again, we're going to just quickly wave our hands and we're going to go and run that first line there and move on. I won't go into much detail about it, just whatever. So in the previous part, we learned how Matplotlib organizes plot making by figures and axes. We broke down the components of the basic figure and learned how to create them. We also learned how to add one or more axes to a figure. We learned how to tie them together with the twinning and the sharing of axes. We even learned how to change basic appearance of the axes with the spines and the ticks and things like that. We went over some various kinds of figures you can make, contour F, P colors, IM show, all sorts of figures we can do. With all that stuff, why are you guys still here? You should know everything you need to know, right?
We don't know how to control our lots of figures.
Thank you, sir. Of course. Because I haven't told you how to speak MPL. I haven't told you the vocabulary of MPL. You know what the pieces are, but you don't know how to describe some of the things that goes on. So, let's start off with colors. Now, I kind of feel like I'm talking back to my son, a year and a half old right now. Colors. There are different ways we can describe a color. There are 3 particular ways. One is color name. So we support multiple ways to specify a name of a color. You can either do, there's 9 single letter names you can do corresponding to these full names: blue, green, red, cyan, magenta, yellow, black, and white. So those are the 9 single character names you can do. A lot of people like those, and again, those who come from the MATLAB background go, hey, MATLAB accepts those as well. The other names we can do are the HTML, CSS color names, such as burly wood and I don't even know how to pronounce that. Chartreuse?
Chartreuse.
Whatever. I'm like Windows 3.1. There's only 16 colors for me. And I even gave you guys a link right there to the 147 color names that are available. And for the British speakers and the poor spellers among us, I'm not saying that there's one and the same. We accept both gray with an E and gray with an A. And so, like, if there's light gray, you can say it with an A or an E, or dark gray, you can say A with an E. We accept both ways, mainly because we have like half our developers are British. So, and they kept getting confused, and then it got me to the point where I don't even know which one's American and which one's British. So, all right. The other way you can do it is a string of hex values. So you give a string that starts with a pound sign and then give a hex value. So if you are used to doing web programming or something, this looks very, very familiar to you. Don't ask me to go and explain it too much, but basically the first 2 are for red, the second 2 are for green, and the third 2 are for blue. So then 256 shades of gray. I don't actually know how many shades you can do, but you can give as a string a floating point number. So the string representation of a floating point number, and we will treat that as a grayscale value. Finally, in many places down in the deep, seedy areas of Matplotlib, we take RGB, optionally A, tuples. Because basically a lot of those, the previous representations, they get converted down into tuples like that, and we operate on those down in the deep underbellies of Matplotlib. Now, unfortunately, we don't accept RGBA tuples in a lot of places in the upper part of the user-facing stuff. Why we don't? That's a very good question, and I've raised this point multiple times on the Matplotlib mailing list, and nobody seems to listen to me. Anyway, but in some places you'll run into things in which they will ask for an RGB or RGBA tuple. That's what they're asking for. I provide a few examples of that as well. So, quick little exercise. Just take this plotting command and just change some of those things to be different colors. So here I have the linear line being red as an R. I have the second line being cyan, and then the third line being 0.7, which is a grayscale value. And you see that works. So you can try out some burly wood. You can try out some hex strings if you want, and Matplotlib will accept them all. So that's how you specify colors. And there's many, many places in Matplotlib where we accept colors, not just in the plot command, but in many other places. This is, again, talking about the vocabulary of Matplotlib. And so where we ask for colors, we accept these things as a way to say it. Markers is another thing that comes up a lot in a lot of places in Matplotlib. So we accept, here's a table of various markers. You provide the string of either a period, a comma, OV, provide a bunch of these, or there's some numbers that you can say. Here's a fun little thing that gets a lot of people confused. There's the Python none, and then there's the string none. Now, in this case, it happens to be nothing in both cases, but in some other places in Matplotlib, there's actually a difference between saying the Python none and the string none. There's actually a difference there. So, won't get too bogged down in that. There is a bit of an error. I'm thinking in version 1.3, we fixed a bug. And since I originally coded this all up against 1.3 that hadn't been released yet, the scatter command worked when I initially tried it, but now that I'm back onto 1.2, this does not work. For some stupid reason I haven't figured out, but just change the scatter to a plot and it will look correct. So here we have ourselves a big diamond with a tick down marker and an X marker. X tick down, really, really tiny. It looks like little bird steps in the snow. If you ever see bird prints in the snow, they look kind of like that. And then big diamond. And so something if you want to play around with, you want to try out some of these other markers that are listed here, go ahead. Feel free. Have a field day.
So how's the math text one's not working for me? How does that work?
The what?
The math text, the last one on the list. Is that
Oh.
LaTeX commands?
Yeah, I have never actually tried that myself.
We're in an error.
Okay, then I just copied this from the documentation. I have never actually tried the math text in this particular context before. So it's probably some really, really special thing that only works in very certain contexts. In a plot context, I don't see how that makes any sense. Probably
use like a LaTeX defined marker or something like that.
it probably is.
Yeah, that's right, because those dollar signs mean that LaTeX, it's expecting LaTeX in between those dollar signs.
Yeah, but what LaTeX stuff can you put in there? And I think it might be some sort of LaTeX marker. So maybe, I think. Yeah, but
I just tried that and like a bunch of Greek symbols. That would be cool. Yeah.
okay, so the Greek symbols work.
Nope.
No? Oh. All right. Well, you know what? File a bug report. We will a lot of these things, like the documentation gets made and it gets copied from place to place to place, but we don't we've been working on building up our test suite. So if something just don't get exercised, and we just know that it's there in the documentation, but nobody ever bothers to try it sometimes. So feel free to file a bug report. We were more than happy to have that taken care of. Maybe somebody knows exactly how it's supposed to work and will improve the documentation on that. So, all right.
Why did it come out in colors? I understand the markers, but why did it come out different colors?
Ah! You know, I completely forgot to add that information into this notebook. So, there is what's known as the PyPlot state machine. This is a little bit of an advanced thing, but again, the MATLAB people would be very happy to know that it exists. In MATLAB, whenever you do multiple plots, it automatically changes the color for you. It color cycles. We do the same thing. If you don't tell us what color to do, for a lot of these plots, we'll change the color for you. Because most people don't want every single line to be the same color. They want each line to be a different color. And so that's color cycling. And so because all we were specifying is the marker and not the color, it went ahead and there's a predefined cycle of colors that it uses to go through. And you can modify that cycle if you want.
But you can also declare the color.
You can declare the colors as well. We give you full control.
What do you call this state again? You said it's in these states.
Yeah, the PyPlot state machine. The PyPlot module keeps track of what it is you have done. And so it knows that, oh, he already did a plot earlier. So I'm going to move on to the next color by default if he doesn't say what color to do. That's the PyPlot state machine. And that's also how it knows what the current figure is and what the current axes are. It's the state machine. All right. Oh.
Yeah, in both of those plans, the one where we set the colors and now we went ahead and changed the marker types, positionally, the color and the marker type is still in the same position. How does it know that it's like a marker type this time and the color thing another time?
So the question was in the position in the plot command, we stated both the color and the marker in the same place. Let me show you something. Let me change this command a little bit so that I do a red diamond and a blue 3 and a yellow X. It just so happens to be that the color specification do not collide with the marker specification. And so if you don't specify the color, we interpret that. And if you don't specify the color, we'll use the color cycle. If you do specify the color, we'll use the default marker. We interpret those strings. So what you're entering in is the plotting specification, which is a combination of the marker and the color.
And how many things can you string together like that?
You can specify a color and a marker.
That's just a color and a marker. It has
And the line style. So there's actually a third thing. You can specify the line style as well.
And does that position matter then? That it has to
It's all in that particular position, all in one thing,
one in one string?
one string.
How do you do a 3 with a 0.75 gray?
So you want a what?
The 3, the middle one,
Yeah?
with a 0.75 gray?
That is a very good question.
Lots of bug reports getting filed today.
I think there's a way of separately specifying the color.
Yeah.
Yeah, but then it will do that color for all of them in the plot. Yeah. File a bug report.
Is it a bug or a feature that I just don't understand?
So if you do,
Right.
I don't know. I don't think anybody's tried to do that sort of combination. I have to take a closer look and see what would actually happen.
I think that's only a problem if you put them all in the same plot statement. If you have separate plot statements for each curve, then you can specify
Yes,
everything.
exactly. So there's always a workaround. There's always a workaround. So, but the question is, do we have a bug in our plot specification that combines all that stuff together? I don't know. I have to take a closer look at exactly if there's a way around that or not. I haven't actually. Very few people actually really use some of those seedier markers. So, yeah, that's good. Good. Point that out. Hmm?
You know, you have that R red diamond and a blue tick down, I think, then a yellow base.
Yeah.
You know, if you have the circle, can you say, I don't want any fill, I just want a line that looks like a circle?
Yeah, we'll talk about that a little bit later.
Okay.
Yeah. Any other questions? All right. Now, I wonder about an orange circle. Well, let me show.
Orange is a basic color.
Oh, orange isn't one of them?
No.
Oh, well, there you go. We don't have a collision there. Okay.
It says you can do it.
Yeah.
I'm looking, I just dropped down the drop-down box for line. RGB, CNYK. You can use the strings too.
Yeah.
Full name. Green Z.
So the next thing is the line style, which is the third thing you can specify in a plot specification. And so you have a dash, double dash. A dash would be a solid line. That's the default. Double dash would be the dashed line. If you want dash and dots, you do a dash dot. If you want dotted, you do colon. I guess that is to prevent conflicting with the point marker. So, and again, none, which is different from a Python none, because a Python none means default, whereas the string none means nothing. So, and then I have a little note here, don't mix up the dot dash and a dash dot. They mean two different things in the plot specification, because the dot dash is the dot marker with a solid line, while the dash dot means the line style. So let's take a look at what we got here. We have ourselves a solid line for the linear, dash line for the square, and then dash dot for the cube. And then for the negative linear, we have ourselves a dotted line. So, see, again, the colors changed because of this color cycling, because I didn't specify the colors. And it does everything as I expected it to do so. And that's what you get. And then an interesting thing I just discovered is that this specification with the dashes and the dots and such do not work when you're actually talking about the line style for, let's say, a patch object. So things like the bar plots and things like that. They want the words, solid, dash, dash dot, dotted. I have filed a bug report. I think that's absolutely stupid, but there you go. You got that. So here, we're going to do a bar plot, and I'm going to say that the line style, LS, is dashed with an edge color, as I was to answer your question earlier, of red, and I'm going to say that the line width of that edge is going to be at 5 points. And there you go. We have ourselves a very thick edge of our artist object right there. And if you look very closely, they are dashed. It looks solid, but you can see little gaps there. Just because I made it so wide, it doesn't really come out too well, but it is dashed. If I wanted to make it dot dash, or is it dash dot? I always, yeah, dash dot. Let me reduce that line width there. That's way too small. Yeah, you can sort of see it. Okay. So now you're starting to see the vocabulary you can use in talking with Matplotlib and saying the things that you want it to do. So there's a lot of other attributes that you can pass to your various functions. And here I have an example of red dashes, blue squares, and green triangles. So this is where I'm now starting to bring together the plot specification with the combination of the colors and the markers. And it works exactly the way you want. And by the way, you then do, okay, why, you can do plot.legend of, val1, val2, val3. I did 3 things, right? And it automatically will, put up the correct marker there for you. And then there's actually a bunch of other options you can do to legend to say, oh, I want you to show only 1 point, or I want you to show 3 of them, or things like that. So that's all available. Oh, again, remember with legend, we can say, come on, go. Why aren't you listening to me? There we go. Loc equals best. See, magically put it in a spot that was out of the way, so I like that. It's not perfect, but it works pretty nifty. So some things that you can specify. Alpha, that's the transparency level. Dash cap style, so you could say butt, round, projecting. These are different kinds of things of how when the dashes meet up at a point, should they be rounded, should they be capped or something like that, and how do they join with a miter, round, or a bevel. What kind of dashes, the draw style. Documentation needs to be a little better on draw style, but that's a fun little thing elsewhere. The markers, marker edge color, or MEC, marker edge width, or MEW, marker face color, MFC. So a marker is made of a face and an edge. So the face, you can specify the color for. The edge, you can specify a color for, but by default, it's the same color as the face. And the edge, you can also specify a width for it as well. Or you can say none. You can tell the edge to be the string none, and it will not draw an edge at all. Or if you want the face to be none and basically be transparent, you can say the MFC is equal to the string none, and only the edge will show up. And so you can actually see through the marker if you wanted to. How does solid cap style and solid join style, that's for the patches. So let's say you have yourself a bar plot or something like that, or some other sort of polygon that's there. How do the edges handle that? Whether or not the thing should be visible. And Z order. The way Matplotlib, so when you plot many things, for example, let me go ahead and put this legend in a bad place. Let me put it at bottom. Was it? Oh, it is lower, not bottom. I like that. The error message actually tells me what the. We need to do more of that. I hate that when I get an error message that doesn't even tell me what the proper values are available, and then I have to go and look for them. And so lower. lower center. So the legend here is on top of the plotting stuff, and that looks terrible. Let's say I want it to be, well, it may or may not be terrible, depending on your taste. Let's see, can I do... Let's see if I can do a Z order equal 0. No, it doesn't take Z order. Okay. A lot of things in Matplotlib do take Z order arguments. And what Z order basically does is says, in what order should I lay these things down? And the 0 or whatever the lower value is to a larger value gets laid on top. And so, but by default, a lot of things don't get a Z order number. And so it's whatever order that it was specified. So if you say plot this and then plot a bar plot, the bars will show up on top of the plot because you did bar after plot. But if I did bar then plot, the line plot will show up on top. Same thing with the legend. The legend was done later, so it shows up on top of everything. So whatever you plotted most recent ends up on top of everything else. And you can, bless you, you can specify explicitly the Z order value. So let's say you're saying that, okay, I want this to be at Z2, but then this thing I'm going to plot later, I want it to be at Z order 1. And it will make sure that that is before that. And so that's a really nifty trick in taking control, especially in more complicated graphs, making sure that all the little elements either show up with everything else or below or above anything else. In particular, markers tend to be an issue. Sometimes markers end up below the line that they're associated with. You want them to show up on top, or sometimes you don't. You know, it's up to you. But by default, they should show up on top. But it used to be a long time ago that they didn't show up on top, and it was really ugly. But all right, next. Let's do an example. Make a plot that has a dotted red line with large yellow diamond markers. And those diamond markers have a green edge. Go ahead. Not that you ever actually really want to make a plot look like this, but it demonstrates my points. Or if you're weird enough and you like dotted red lines, you know. Oh, right, yeah. We're going to do line colors red. Going to be dotted. And we're going to do marker Can I say marker? Okay. And then. Did I get it right? No. Ah. And there we go. So we have C color being red, the line style LS being dotted, the marker being a big diamond, the marker face color being yellow, the marker edge color being green, and then the marker size being 10 points. Some large number. Now, of course, first you go, oh, where's the dotted line? Look over here. Early on, you can see that. By the way, there is an ability to increase or decrease how often a particular marker shows up. Now, in this case, the way plot works is that plot is going to be putting a marker at every data point for the most part. So we can increase that to, let's say, 0.5, and it will do it less often, and you guys should get better spacing. But then, you know, it's a lower resolution thing, and so there's a property called mark every, and so I could bring this back to 0.1, and then, assuming that this still works, mark every, let's say every 5 points. Yep. So now we see that it's smoother. The line is smoother, but it's going to do every 5 data points and mark it.
Does that work in other functions then?
And a bunch of other functions. It's not ubiquitous as some of the other things are, but yeah, you can see mark every, I know, is in error bar. Let's say you're plotting on the line, but you don't want an error bar for every single thing. You could say, I want to mark every other one or something like that. You can see mark every in a bunch of different places. It's not everywhere, but in the documentation, if you see mark every, that's what it's for.
So how do you use the order so that the line goes above the marker?
Oh. That is a bit more surgical. We don't make that particularly easy because we assume that the marker is going to be the same line. The quick and dirty way of doing it is you do a plot of just the line after you do a plot of the scatter points. So you call scatter for the markers that you want. Then you call line after that. You call the plot after that. That's the quick and dirty way of doing it. So you basically split it up that way. There are other ways you could deal with that, but you have to capture that object, and then you have to go really dig down into it and deal with it. So really, the answer is yes, there is a way to do what you want to do, but it's probably easier to do the workaround than do the right way. So.
You know, I tried it a little differently. I said that plot, PLT.plot, and then T, comma A, and open quote R, colon, close quote, comma T, comma A, and open quote Y, big D.
Mm-hmm.
Could you do that way?
That is another possibility. What you're doing is you're doing 2 separate plots.
There's 3,
right.
on top of each other.
Can you imagine, though, if you had to add a legend, though?
Yeah.
That would then screw up the legend because then you would have an entry for each of those. But no, that would work, yes. All right. Next topic, color maps. A lot of people, color maps are an interesting issue, and there's a lot of discussions that happen about color maps in the Matplotlib mailing list. And as scientists, we want to communicate our information properly. And the color maps are there to help us do that. But a lot of scientists really don't put much thought into the choice of color maps. And they'll typically just go with the default jet. That's what Matplotlib uses as default. That's what MATLAB uses as default. That's what other older plotting libraries have used for the longest time. And it can be proven scientifically that jet is probably one of the worst choices you can possibly make for your color map. But I'm okay with leaving jet as a default because pretty much any choice and making it default in Matplotlib will be the wrong choice for a wide swath of people. And so it really behooves you all to take a look at the sort of color maps that are available in Matplotlib, or make a custom one yourself that really works right for your data set and what you're plotting. And I really want to just kind of point out and thank a couple people, just acknowledge their efforts, Nicholas Ruggier and Tony Yu, for really pushing a lot of discussions about color maps in Matplotlib, because before we weren't really thinking that much about them. We just had everything default to jet. And now we're really starting to think about, well, you know, maybe we should be using some different color maps. And so a lot of our examples now use different color maps just simply to showcase them. We still want you guys to think and choose which one is right for you. But and so Tony Yu put together this particular example that kind of breaks down different kinds of color maps that are predefined in Matplotlib and break them down to how what sort of data sets they might be useful for. So we have sequential, diverging, qualitative, and miscellaneous. That's how he broke it down. Nicholas Ruggier, he broke it down a little bit differently. But let's run this example here. So if you want to see all the different predefined color maps that are available, we have them right here. I typically like having, when I need to make a choice of a color map for a particular project or something like that, I open up to the gallery page entry that has the color map, and there's an example that just has all the, basically this example, it just has them all listed right there, and I'm able to choose, oh, okay, yeah, I need this one, I need that one. All these color map names you can specify as a string wherever we ask for a color map. And then if you want the reverse of it, you can do _R to that name, and it will be the reverse. So if the sequential color map, for example, that binary, I can say binary _R, and it will have black to the left and white to the right. You know, it's kind of like that. But only the predefined ones do that. Then there's other sort of sequential ones. We have diverging color maps. And we have qualitative color maps. And then finally the miscellaneous, where you'll find jet is in there. And so, who the heck ever came up with flag? I do not know, but it's there in MATLAB, and so we have it too. Yeah. Prism, actually, a lot of people ask, when would you ever use Prism? I like using Prism as a quick and dirty way of coming up with a color cycle. you know, if I'm plotting a bunch of things and I want to make neighboring things not look like each other, but I know the neighboring things are going to have similar values, so I use a prism on there, and then therefore it's a quick and dirty way of making neighbors not have the same color. So, all right. So you can, and so here I show, following an example, I show how you can use different color maps. So I show a particular random number, and you can see how two totally different color maps look different based on your choice of color maps. And so how you want that to work for you, again, it comes up with your choice. To go a little bit into how color maps work is that there's the color map object, and then there's the norm object. And so if you don't specify it, so when you apply a color map to your data, and you don't say what your C limbs are or your V limbs are, value limbs or color limbs, some places they say one, other places it says other, it will go to the min and max of your data that you have. And so it will pick the min and max of it as is and work with that. You can override that if you want, and you can actually then build up your own norm object to process your data in a certain way. So you can do a log norm, you can do other types of norms. It's depends on what you want. But you can, if you really need that sort of control, we have it there. You just have to look it up in some of the examples, some of the more advanced things that you can do. But if you need, but it's particularly used when you want to do a logarithmic normalization, but you don't want to put your data through a log, you know, because you want to keep the data as is. You can do something like that.
Question. The color of cool warm, should I find that in the list above?
You should. Cool warm should be there. Yes, there it is in diverging color maps.
Okay.
All the ones that are predefined you can specify by a string, and then if you custom make one and you give it a name, that's another one that you can access by name. It's called registering a color map.
So when you give a color map, is that the range of colors it will use for a given plot, or how is it used? Like you in a plot command, or you use it by only range?
For the individual plot, if you don't specify anything, it's going to use the range of values. Because basically what IMShow does is produces a scalar mappable. And the scalar mappable by default will extend the range of the data you have. Then you can predefine what the limits are, and you can predefine certain advanced behaviors to how to treat data that's below or above your limits or are invalid, such as NAND's infinity is always, positive infinity is always treated as over, and negative infinity is always treated as below. But I've seen some really crazy stuff where like the data is a bunch of strings, and so somebody created a normalization object that actually took the string and printed out a number, and then that put it to a color map. It was the craziest thing I've ever seen, but it operates on the data you give it. And so this CMap gray worked on that. I can do another plot within this, and that color map doesn't affect that. The color map is assigned to the plot that you just did. And so each one gets its color map. Now, if you don't say what color map you want, it will pick the default. And the default is jet. But you can override that default too by saying plot.set CMap. And you can say what the default color map is going to be. Yes?
I think maybe it's worth mentioning that people worry about color maps for color blindness also.
Yes.
And there are tests online for that to see if how your figure looks for different diseases. But most of these color maps are aimed at fixing that, especially the diverging color maps. But it's still good to think about for your application.
Absolutely, and that's one thing I don't like about our choice of the color cycles, is that we have blue and red nearby each other, and a lot of, or green and red right next to each other in the color cycle. I think that's the stupidest thing, but because MATLAB did it, we do it too. And a lot of people have a red-green color blindness, and they don't see the distinction between them. So, but yes, that is another reason why you want to take that into consideration. So some of the work I've been working on is, because also I do a lot of publications in papers that they charge an arm and a leg for color publication. So we would do black and white publication. Instead, what I would then do is I would like to cycle the hatches instead. I think hatches are much better anyway because it's a lot clearer and you have total control over what happens. So I've been working on a patch to Matplotlib to allow for a hatch cycle if I wanted to, or I just specify what the hatch is. I'll talk about hatches in a bit further down, but that's another way to bypass color blindness issues. Any other questions? Okay. Math text. So all you LaTeX lovers out there, that includes myself, we have a fake way of doing LaTeX. We also have a direct way you can do LaTeX as well, but we emulate a lot of LaTeX ourselves. We interpret very simple math text. We don't do the full set of math text, but we do the simple set. And what you do is any place where you're doing a label, any place you do a label and there's going to be text that's going to show, you can put that with $signs around it, and you can put in your math text, and we'll interpret it for you and put it up and make it look like LaTeX did it. And then there's actually a way you can actually make it LaTeX actually do it. But a very good convention to do, because a lot of LaTeX commands have backslashes in them, and because backslashes are treated as an escape marker, is you put the R right there before the string. And what that means, it tells Python to treat this string as a raw string. So do not interpret the backslashes. And so in this case, a backslash S doesn't mean anything. But if you had a backslash NU for new, for the new character, but a backslash N, if you didn't have the R there, Python's going to go, oh, you want a carriage return. And so you end up with text that started with something and ends with a U on a separate line. You know, it doesn't look right. So you have that R. So generally speaking, whenever you're doing math text, put that R there just to be safe. Okay? But you can see we have ourselves a sigma with a subscript. That's how you do it. It's that easy. Annotations and arrows. This is a fun little one. So sometimes you literally do want to point something out on a plot. That's how you do it. You literally just point it out. With an annotate function, you provide the text for what you want be said. You say where that text is going to be in data coordinates. So you're going to put it at I'm sorry, you point out what it is you want to point out. So 2, 1 is the point in the local max. And then you say the XY of the text, it went to 3, 1.5. So that's where it was. And then you say, okay, I want an arrow that is black, that's slightly shrunk, and and it draws that arrow for you. There's a whole bunch of arrows that you can have, and so the next thing kind of plots out for you the different ways you can specify an arrow. So if you want just a simple line, that's just a dash. If you want an arrow, you do dash and then greater than sign. If you want arrow both ways, you can have all these different kinds of arrows that are available. And these are the different ways you can specify it. So here, we're going to do a little exercise. Let's try to make, let's not point out the local maximum, let's point out the local minimum and make a red arrow of your choice. Mm-hmm.
You know, those latex math symbols that you talked about earlier, is there a list of them?
The map commands, the map text commands, or?
No, the list of different types of math symbols you put into a grid. Like I see sigma underscore I, that means the sigma with the I underscore. Are there more?
Okay, so the question is, what is it that Matplotlib accepts as math text command? Basically, just about anything you could do in LaTeX as a simple thing, as a simple thing that you would put between $sign. None of the complex, blocking of commands and things like that. We don't do like full out equations or anything like that. But if you had a simple thing that in math text would have just been something between $signs, there's been very few things that I've come across that we couldn't handle. And then if we ever did needed to actually have LaTeX handle it, you can set up a variable called useText, so USETEX, and you set that to true, and it actually will pass things off to a LaTeX environment and have it return back to it. So if you ever really needed that, that is there. I'm not very good at that. I've rarely ever, I think I've used it once because I really needed a particular symbol, and at the time we had a bug with that. But for the most part, we handled just about anything you could throw it. Mm-hmm. Right. Mm-hmm. And so for this particular exercise, I'd like to try to fill in that dictionary. So you take a look at the previous example, you sort of see how I used that earlier, and you try to fill in the appropriate things.
Suppose you want to point out all the commands.
Ooh.
And then, so create a 5, but then that thickens the font itself.
Yes, because you're basically
Right.
putting the same thing
Right.
again and again. We assume with annotate that you're only going to point out one thing. There's probably a way that you can have multiple arrows to the same text. I haven't thought about that. What you can always do, you can always call the text function itself, put the text there, and then call the arrow function itself. Annotate is just a combination of the arrow function and the text function. So if you really want to do some sort of advanced thing like that, you can call arrow multiple times with one text. So, all right. So let's see. So the local minimum is, let's say, at -1, 2.5. Oh, 2.5 -1. Oh, right, it's called local minimum. And let's say arrow style will be Yeah, it's not very big. No, it doesn't accept mine. Oh. Oh. Edge color. There we go. So now you start seeing how you can combine this vocabulary you've been learning in these various places throughout Matplotlib. You know, you see these things show up again and again. Line width, LW. Edge color, EC. Now you have arrow style as another bit of your vocabulary. All these things get specified in different places in Matplotlib, not just in Annotate, but in other places. And so when you see in the documentation, oh, specify these properties, this is what we're talking about. This is how you speak MPL. One last property one last major property we'll discuss is hatches, which I was talking about just a moment ago. Where you could do a fill, but you could also hatch your polygons. And there are different ways you can hatch them, and you can combine them. So let's say you want X's, well, actually it's not X's, it's diagonals with circles or with a vertical. Or something. You can do that, and then if you repeat them, it would increase the density of the hatch. So just to kind of show with this example, you look, I really should have picked it. Oh, yeah. So what I did was I did this bar command, and I saved the object that gets returned by the bar command. A lot of people don't bother saving the stuff that comes from the plotting command, but you can. It's the objects that actually get put there. And then you can set P on a particular one. So there's 4 bars. So I just did it to the first one, because this is just a list of the bars. And I said, I want the hatch to be an X, the base color to be white. You could do that. Now let's do something to the second one. Plot.set P bars 1. Let's make the hatch be really dense vertical bars. So just double that up, and face color equal. Let's do a grayscale thing. See? Guys, all dense vertical bars. Works out great. There's some file outputs that we're still working on that doesn't quite get the hatches right. So sometimes in like the PDF format, the hatch doesn't quite look right. We've gotten most of those kinks worked out, but in version 1.1, you may notice, if you're still using that version, you may notice some issues with hatches. We've gotten most of them worked out. Anybody using the Mac OS X backend, you may notice that sometimes you specify the color one way and it doesn't come out that. We're still working on that bug. We haven't quite figured that out. It doesn't mean that it happens if you're using a Mac. If you're using the Mac OS X backend. So if you're using the, let's say the Qt backend on a Mac, it works fine. It's the Mac OS X backend that is a little weird. So, okay. Transforms. I'm going to quickly talk about transforms because it's the part of the vocabulary, but I'm not going to get into too much detail about it. There are 4 particular coordinate systems in a figure. you have been entering in stuff in data coordinates. So you said that this bar is, 17 high, that this one is, such and such. We've specified these things and then locate at this x coordinate, this is the data coordinates. That's one coordinate space. Then there is the axes coordinate space, where this is 0, 0, 0, and this is 1, 1. Then there is the figure coordinate space. That's the space outside of the axes, where it goes from 0, 0 to 1, 1 up here. And finally, there is the screen coordinate system, which you almost never have to worry about. That is the screen that the figure exists in, where it's 0, 0 up here, 1, 1 down there. Most of the time, you do not have to worry about this, but this is how Matplotlib is able to do a lot of its magic, is that we can say that this tick mark, or this tick here, is at data coordinate 4, but at axis coordinate something just, negative 0.1, just outside of the axes. So we could say that, x coordinate is in data space, but in y coordinate is in axis space. And so we do these transforms, and that's how we can make a lot of this stuff work. So even if you change the limits, the legend still stays exactly where it's going to be. The y-axis labels stay exactly where they're supposed to be because they aren't affected by the data coordinates. So it's a nifty little thing. It's good to know that it exists. And there will be times where you'll run into it in the documentation. And so it's good to know what it's for. Most of the time, you will not need to deal with this. But when you do, it is there. Finally, the last part of this section is called, we talked about a lot of things in this section. And now you go, wait a minute. I said that I provide full control over all the defaults. How do you do that? And that's the Matplotlib RC file. If you run this command, import Matplotlib, and then print matplotlib_fname, it will tell you exactly the file that it is using for this RC parameter stuff. And it looks like an any file, in which you have, in square brackets, a name of something, and then something equals something else. And you can specify all these, and you just see in there's this huge list of things that you can specify, and you can modify these RCs so that your plot looks different by default without you having to even specify all this other stuff if you wanted to. Also, you don't even have to mess around with the file. You can actually mess around with the RC settings live in the program. So this is here, because I'm going to be messing around with the RC settings, I just want to make sure that I start the cell with the defaults every time. Here I'll be doing a regular plot that's going to look like the way it does normally, but then for the second plot, I'm going to change the line width, I'm going to change the style. This is the RC param. So now notice that the plot command still going to be 1, 2, 3, 4, but I'm not going to say what the line style is or what the line width is. There we go. I changed what the default was. This goes back to what none means to Matplotlib. None in Matplotlib means do the default thing. So if we come across ls equals none, we go and refer to the RC params and grab what the default is there. And so if you want to play around with your own default file, you can. And that's how you do it. Or you can play around with some of these RC param live and do that. Note, if I take out this RC defaults thing and I run this, it's going to look right, well, because I changed the default from the previous run, the RC param is global. So I ran it again. Now the first time I did that plot, it did that. So if I leave the RC default in there, yep, plot dot, oh no, it's mpl dot oc. There, now I restore the default each time I run that thing, and it does everything right. And if you want to learn more, you can go to the customizing Matplotlib link that I have there at the bottom to learn more about that. All right. It is almost 4 o'clock, 3:50-ish right now. There's 2 more sections, but they're really, really short. We'll probably do that in one breath. If you guys want to take a 5-minute break, we can move on to the last 2 sections. I expect the last 2 sections to take only about 20 minutes.